So now we saw some simple examples, and in those examples you only had one substituent, so you didn't have to worry about putting the substituents in the correct order. But when you're using these prefixes, iso, sec, and tert, what gets alphabetized? Remember that we do not alphabetize di, tri, and tetra. I told you that in the last video. You also are not going to alphabetize the prefixes sec and tert. Now remember that you will alphabetize iso and cyclo. So this is a little bit confusing. It's a little hard to remember what you alphabetize and what you don't. But just think of it this way. When you're looking at something that's telling you the number of substituents or the number of different types of groups, you do not alphabetize. You ignore the di, tri, and tetra. If you look at these names, now these are telling you something about the structure of the group or the substituent, iso and cyclo, sec and tert. But sec and tert do not get alphabetized while iso and cyclo do. And the way that I think about this is that sec and tert refer to a number. It's not the number of the different types of groups that are present. It's the number of the carbon, right? Or the number of carbons attached to that carbon. It's really the only way that I can remember the difference between sec, tert, and iso. So iso is telling you something about the structure. It's not telling you anything about a number, or it's not referring to a number, where sec and tert do refer to a number. So sec and tert do not get alphabetized when you're naming compounds. So let's go ahead and look at an example where we have to decide how to alphabetize our substituents. And we also have to decide how to number our substituents in this example as well. So we have a six-membered ring, so this molecule is going to be a cyclohexane. My substituents here are methyl and isopropyl. 3 carbons attached at the second carbon is an isopropyl. So how am I going to alphabetize this? I also want to remind you about the numbering of the substituents now, or identifying the locants. Now that we have 2 substituents, or 2 groups attached to that 6-membered ring, we are going to have to give numbers to those substituents to tell you the relative positions of those groups. And remember, if you have 2 or more side chains in equivalent positions, the one assigned the lower number is the one cited first in the name. The one cited first in the name will be the one that first alphabetically. Is isopropyl going to be before or after methyl? Well, remember that we do alphabetize the iso, so we look at the iso, not the propyl, when we put these groups in alphabetical order. So this is going to be 1 isopropyl, 3 methyl, cyclohexane. And we alphabetize according to the I, not the P. Here's another example. We still have cyclohexane, and on that cyclohexane we still have an isopropyl group, but now I've added in a second methyl group. So this is going to be dimethyl. So how am I going to put these in order? They're going to be some derivative of cyclohexane, but which comes first? Well, remember, I do not alphabetize the di, tri, tetra, sec, or tert. Anything that refers to a number, I do not alphabetize. So this is going to be 1 isopropyl, 2,3-dimethyl cyclohexane. And we alphabetize according to the I for iso, not the D for di. So there you go, a few examples of nomenclature when you have substituents that are branched. So we've seen a few examples of these branched substituents, and there are others that we haven't talked about yet. And what I'm showing you here on this slide are all of the branched substituents that have common names that are authorized by IUPAC. And we've seen the first 4, the 4 on the top row, isopropyl, isobutyl, tert-butyl, and sec-butyl. There are 4 more that we haven't talked about, and I'm showing them here to you. Now, I'm showing in red. So the red bond is meant to represent where the substituent is attached to the parent chain. So at the end of the red bond, that would be a carbon that is part of the parent chain. So for instance, in the isopropyl, only the bonds that are shown in black are part of the actual substituent, and the red bond is where that substituent is linked to the parent chain. So the other groups that we have are isopentyl, and that is from isopentane. So if we're attached at the primary carbon of isopentane, that is an isopentyl group. Neopentyl is derived from neopentane. So if we are attached at any one of the carbons of neopentane, that gives us a neopentyl group. If we attach the isopentyl group at the opposite end of the chain, or in other words, we take the isopentane molecule and attach it to a parent chain at the tertiary carbon, then we call that tertpentyl. And finally, we have the isohexyl group. So all of these names are authorized by IUPAC. I want to mention to you that while we have common names and systematic names for some small molecules, we can also name these branched groups systematically. In Chem 2200, I'm not going to require you to know how to name branched substituents systematically, but I just want to show you a few examples in case you come across them in your reading. And these are the 4 examples that we saw in this video earlier that we named. What you're going to do is you're going to number the longest continuous chain of carbons in the substituent, starting from the point where the substituent is attached to the parent. The point of attachment is always number 1, and then you number from there the longest continuous chain of carbons, just like you do when you name an alkane or any other molecule. So here we have our numbers. So if we look at our cyclopentane group in the upper left corner, you can see that you have a 2-carbon substituent with a 1-carbon branch. So this is an ethyl group with a methyl group attached at the 1 position. So the way that I would name this substituent would be 1-methyl-ethyl. Name of the full molecule is 1-methyl-ethyl cyclopentane. So that is the systematic name. So we're using the systematic nomenclature to name the substituent. Our next example right below is 1-methylpropyl cyclohexane. So our longest continuous chain, starting from number 1, which is the point where it's attached to the parent, is 3 carbons, so that's a propyl group. It has a methyl group attached at position 1, so it's 1-methylpropyl. 1-methylpropyl cyclohexane. Our next example, looks like I've spelled cyclohexane wrong. Sorry about that. Our next example would be 2-methylpropyl cyclohexane. So we have a 3-carbon group with a 1-carbon substituent at the 2 position. Our final example would be 1,1-dimethylethyl cyclohexane. This is the systematic way to name substituents. I'm not going to expect you to know this, but I do expect you to know the common names for all of the branch substituents we saw in the previous slide.